Okay, great. Thank you all for coming. My name is Jonathan Kelly. I appreciate the warm introduction. Uh, yeah, I'm the creator of Dioxys, the founder of Dioxys Labs. Recently, we went through Y Combinator, so like the startup school in San Francisco. So now we're a legitimate startup. It's pretty cool. I've been working on Dioxys for a little over 2 years. I think my last commit was like 2 years ago. It's been public for about a year and a half. Before Dioxys, I worked at Cloudflare, spent some time at NASA. Dioxys is a lot bigger than just me. There's an open source community. We have 150 like open source contributors, 170 I think, and 3 lead maintainers, and then there's a full-time engineer beyond me. So I've got a good pedigree. Dioxys is open source. I mean, we're here. This is an open source conference. We have a fairly large community. We have 14,000 stars on GitHub. We have a lot of active community members, a big ecosystem. Everything's written in Rust. So we're fulfilling that Rust track at GoSim. We have one goal, and that's to fix cross-platform app development. So this is pretty ambitious. Building apps is very challenging. I don't know. I'm sure everyone, we're web and in this like app development conference. It's very difficult, especially with the amount of platforms today. And you only see more and more platforms coming out. So obviously we have web, desktop, mobile, but there's cool new exotic targets like smart cars and smart tractors, self-driving vehicles, spaceships, right? I think the Falcon Heavy launched with a web UI written in Electron. So there's certainly room to improve. The biggest problem, in my opinion, is that in 2023, like this year, your users expect your app to be on every platform. So for an example, everyone tends to have a music app on their phone. In the US, we use Spotify, generally across the world. Spotify has a desktop app. I use it every day. I listen to music every day. They also have a mobile app. I couldn't live without the mobile app. I get in my car, I need to play music. Sometimes I'm on a different computer. I need to use the web app. A lot of times you go to someone's house, it's a party, they're playing it on their TV. Obviously, you have it on your smartwatch. You got to control your music somehow, and even on like smart speakers. So if you, like just a humble indie app developer, wanted to compete with Spotify on any of these things, you have an uphill battle to climb, right? You have to make an app for every single platform, and this is a ton of work. So if you needed to sit down and do it yourself, you would probably build an iOS app, and then an Android app, and then maybe some new operating system that has come out recently. You need to build a web app, a desktop app, Mac, Linux, Windows. There's so many platforms to keep track of. If you're going to do it natively, which typically the big companies like Spotify do, you need like 7 or 8 different programming languages, and you need like 100 different tools. So competing with Spotify, competing with Apple is pretty much impossible. There are options out in the world, though, to make this easier. And they're getting more and more popular. Some of them less so. There's a huge graveyard of cross-platform app development toolkits out there. A lot have died over the years. Some of the more popular ones these days, Jetpack Compose on like the Android side of things, Xamarin, which is like a web-focused C# kind of library, Apache Cordova. The ones we know and love typically are React Native, which is Facebook's foray into this. They're using it to power their next generation of augmented reality headsets, which may or may not come to fruition. It's a hard problem. And then Flutter. So I've come to learn that Flutter is very popular outside the US. Inside the US, we tend to use either Swift or like Android natively, like targeting those platforms natively, or go the React Native route. So I think 3 of the top 10 apps on the iOS App Store are React Native apps, which is a very good track record for a cross-platform app framework. If you stick with Swift UI or Jetpack Compose or any of these native toolkits, you do get really good code reuse. So you can write your app or your business logic and then put it on your smartwatch or your smart speakers or your smart TVs, right? So Apple has a huge ecosystem of devices that you can write your code once, for the most part, and ship it everywhere. You need different screens for each app, but for the most part, you can share things like data fetching, caching, hard logic that makes apps complicated to build. But Apple's Swift UI, UIKit, their ecosystem is stuck on Apple's hardware, which is very popular in the US, but not outside. You need Xcode, you need a MacBook Pro, and you can't serve the 3.3 billion global users running Android. It's a lot of folks. Or the like 1.4 billion users running WeChat mini apps. So you're not building iOS apps like that. So you can stick with some of the more popular options. React Native being the most popular for desktop, mobile, web. If you're going to build a desktop app, you're probably going to use Electron. If you're going to build a mobile app, you're going to use React Native. And if you're going to build a full stack web app, you're going to use Next.js. So you can put your app on Vercel's hosting platform. You get all the integrated tooling. But none of this tooling works cross-platform. So Next.js tooling doesn't work with React Native, and it doesn't work for Electron. And each of these technologies have some like pretty big trade-offs. Right? With Electron, you're basically shipping Google Chrome to every user for every app. So for something that's just meant to play music, like we had MP3 players 20 years ago that didn't require an entire web browser, we're getting pretty wasteful. With React Native, it has been an uphill battle for the past decade for performance reasons. It comes to show that running JavaScript on low-end hardware is probably not the fastest, most performant way to build an app. It is the easiest so far, but when you have devices in the field that are 10 years old, that have very old JavaScript engines, the most cutting-edge version of React is not going to cut it. And you're in JavaScript, so you're stuck in the JavaScript virtual machine, which means you actually can't touch the hardware natively, which is great when you're shipping web apps and you don't want people to hack into your computer, but if you're shipping like a self-driving car, you need direct access to the hardware. What was a feature is now a hindrance. It's now a roadblock. Now, Next.js is pretty good, so I think it's a good model of what we want to become. It's very powerful. You can share a lot of code across your entire ecosystem. It's good for building backends, like server-side rendered backends, but it's not good for any other UI use cases. And that's what we're trying to solve, is the lack of code reuse across all your platforms. If you build a button or a slider for React Native, you can't share it with any of your other projects. Some logic can be reused, sure, but if you're relying on any sort of native libraries, like a Node library, you just can't get React Native and Next.js to work together. And Flutter does kind of fit the bill, but it has a lot of the same issues that like JavaScript runtimes have. So what is supposed to be a sandbox feature becomes a roadblock. So you need to make binding libraries for Mac, Linux, Microsoft platforms in a way that makes it very hard to scale an ecosystem. So for example, the Rust crates ecosystem is 125,000 packages large. I believe the Flutter, the Dart pub.dev is like 35,000 libraries. So there's a huge disparity in like the amount of tools that you can use. So with all that in mind, I built Dioxys. We're going to talk about Dioxys, the architecture. We're going to build an app together. So we're going to do some live coding. We're going to explore some of the interesting architectural decisions and why we did what we did. First and foremost, Dioxys is written in Rust. So we have a very interesting budding ecosystem. So when we think about what is the future of app development going to look like, we kind of have to pick a language. So in Flutter's ecosystem, they chose Dart. Dart is not the most popular programming language. It was originally intended as a replacement for JavaScript, and there are a lot of Flutter developers running Dart out there, but no one is building backends or doing machine learning or scientific computing or building flight microcontrollers. Any of the things people are doing in Rust, they're not doing in Dart. So it's good for UI, but it doesn't have this large ecosystem of anything else. And the Rust ecosystem is pretty powerful. So it's been the most loved programming language for the past 8 years. It runs natively, so there's no garbage collector. You can put it on the smallest of single-board computers or self-driving cars. There's no problem. And there's a lot of really, really good tooling. So it's setting a new standard for what a programming language should be. So things like Cargo, the package manager, are incredible. RustDoc, the integrated libraries system, the documentation for your libraries is above and beyond anything else in any other language. And you can cross-compile using LLVM, the low language virtual machine, to most major platforms. There's very few targets that you can't reach. And yeah, I mean, when I went out to build Dioxys, I wanted to play into Rust's strengths. So number one, Rust can cross-compile basically anywhere. ARM architectures, x86. If you work in embedded, you know STM32s. WebAssembly a new budding target, targeting the web. There's no user Rust can't reach right now. There's no screen that a device is attached to that you can't cross-compile Rust to. And you can't say the same about JavaScript, Python, Swift. So our UIs should be the same. Our widgets and buttons and components should work and look and feel the same no matter the target. So if I spend an hour making my button look pretty for my web app, I want to be able to use that exact same button for my mobile app. Number two, Rust is fairly low level. It gives us the power to manually manage memory and performance, but it also gives you a very high level, developer-oriented API on top of that. So Rust gives us the ability to manage these complicated things. And it enables library authors like myself to build very ergonomic APIs that wrap some very complicated high-performance logic. It's Rust, it scales, it's blazingly fast, it can even run on like a smart TV or a toaster. So we shouldn't be really concerned about performance for any of these things. We shouldn't even be checking benchmarks, really. I mean, we're at the top of the benchmarks, but you shouldn't have to check the benchmarks to know that Rust is stupidly fast. And number three, I think is the most important, is that Rust prioritizes developer experience, making it faster to put apps into production. A type-safe system that prevents you from shipping terrible runtime bugs into the largest of scalable systems. We love Cargo. We love RustDoc. We have integrated testing. The error messages are fantastic. So as library authors like myself, we should be leaning into this and focus on designing clean, simple libraries that make the appropriate trade-offs between performance and development speed. We should be seeking to find a good enough solution without getting caught up in the ideological weeds. There's been a long-running gag in the Rust ecosystem that there are a lot of prototype libraries out there. So there are over 50, 60 GUI libraries out there that have come before Dioxys. So we're not the first in this battle. But everyone seems to be making these design decisions and building prototypes without ever trying to get something into production. People are exploring the space, but nobody is taking it seriously. Our goal with Dioxys is to take it seriously. I mean, the ecosystem agrees. There are over 50 GUI libraries. Rust could be an amazing language at this. We just haven't figured it out yet. So how do we get everyone on the same page? What do we need to do to make a viable alternative to Flutter or React Native? So that's what this talk is about. That's why I built Dioxys. I've spent the past 2 years working on this, and we made some interesting choices off the bat that I think will benefit to Dioxys' success in the long run. Our goal is to take on a lot of the big app frameworks like Swift UI and Android Studio. So we have to make really good decisions off the bat. First and foremost, Dioxys is declarative and component-based. I think it's pretty obvious that this has won out. If you look at the React ecosystem, JSX is by far the most popular way of building UIs. Even libraries that brand themselves as like React alternatives still embrace JSX, this like HTML code hybrid where you can attach event handlers into elements. And you're not manually managing like the color or the text of buttons. You're letting the framework do that for you. We're React inspired. So React is the most popular UI library almost ever. I think it has captured so much mind share over the past 10 years, and it doesn't look like it's going away anytime soon. You see new libraries come out trying to challenge that paradigm, but React has staying power. Dioxys uses a virtual DOM, which is an interesting implementation detail if you know a thing or two about how UI frameworks work. This is a choice that some people care about, some people don't, but we went the path of using it. People typically critique this because it adds an additional overhead to your system, but in our case it allows this render agnostic framework architecture that we have. So we can target a numerous amount of devices without ever changing like the rendering layer at its core. We're cross-platform. We're trying to solve this. We're trying to be on the most exotic of targets. Someone in Iowa is running a self-driving tractor with Dioxys on it. So we have to be in these crazy exotic environments. We target the web, desktop, mobile. We even have the ability to render in the terminal. So we'll show off that. That's pretty cool. And there's a bunch of interesting web-based targets as well. And this is kind of where we differentiate ourselves from Flutter. You're not going to go build a server-side rendered e-commerce site with Flutter today, right? You're going to build something highly interactive. You're going to build something with animations, SVGs, But you're not going to put something out there that you want Google to index, because that's not what Flutter's good at. But if our goal is to be the final GUI framework out in the world, we have to think about these things that people are using things like React for today. We wanted exceptional performance. We're at the top of the pack in terms of web-based frameworks, and our rendering layer is swappable. So you can put in anything you want to get whatever performance you want out of it. DiAxis imposes only like a 4% overhead over like manually managing all the buttons and text yourself. So it's basically imperceptible. And then leaning into Rust's like developer-oriented focus, being a great framework for developers to build and ship quickly, we wanted to include important features from the Flutter ecosystem, things like integrated dev tools and hot reloading. So you can edit your app without recompiling. The interesting detail I mentioned about the virtual DOM, I think it's important that we like kind of understand this before we move forward, because it's fundamental to how DiAxis works and how you go about building a DiAxis app. Virtual DOMs are not new in the field of UI. React has been doing it, and libraries before React have been doing it for 20, 30 years. But I think React is a great source of information on this, so I'm going to paraphrase their description a little bit. The virtual DOM is a programming concept where an ideal or virtual representation of a UI is kept in memory, like a tree, and synced with the real DOM by a library such as DiAxis. The process of syncing the in-memory tree to the real, what you see on the screen, is called reconciliation. This approach enables the declarative API of DiAxis. You tell DiAxis what state you want the UI to be in, and it makes sure that the rendered screen matches that state. This abstracts the typically error-prone manual manipulation of DOM elements that you would otherwise have to do for your apps. And what this lets us do is separate DiAxis into three main Lego blocks that you can put together. So you can assemble any combination of these and get an entire DiAxis app off the ground. At its core, DiAxis provides DiAxis Core. So this gives you all the things like React state management solutions. So hooks, context, signals, and then the virtual DOM. And these are concepts that we're borrowing from other ecosystems. We're making the choice to steal from the best and invent the rest. This plugs into the widget layer. So by default, we believe HTML and CSS is just the best option because it's the most popular. Everyone knows it. Everyone knows HTML and CSS. There's a ton of documentation out there. We don't really have to invent our own concept of the widget stack. We can just steal it where it exists. But some pioneering community members out there have already built different widget stacks. So you can plug into the Flutter widget stack if you want, or you can go from scratch. Someone built something called Freya UI, which I'll actually show off in this talk, that they've implemented their own widget stack based on Skia. And this gives you things like custom elements, new rendering prototypes. People are working on augmented reality, virtual reality, so integration with Bevy, like the game engine, and DiAxis, so you can render cubes and trapezoids and shaders and stuff all on the fly. This all pipes into that final rendering layer that you can pick and swap, and you'll do that for every project. By default, we have a bunch of rendering layers, so web, desktop, mobile. These things use WebView and WebGPU. But you can pick and choose from anything. So Skia is a popular thing. That's what's powering Flutter. eGUI is like an immediate mode for game engines. MakePad, we talked about earlier today. No one has written the integration yet. I think MakePad's still a bit of a moving target right now, but there's nothing that says you can't pipe the DiAxis widget layer into MakePad. And the way this manifests, finally, we get to some code, is what a typical app would look like. So if you can see it, we have this useState hook. If you're familiar with React, this should make you feel right at home. We're saying we're going to store some state between renders. That's what this 0 value is. This is the same for all DiAxis apps that you write. So if you're going to abstract some state and want to use it in a desktop, web, mobile app, this is where you do it. So things like interacting with WebSockets or the file system, hardware, location, GPS, Bluetooth, happens at this like ground-based, like number one on the stack, state management. And then number two, you see the widget layer. So this div, hello world, is just an expression of HTML and CSS at that layer on the stack. This is entirely swappable. So when you go to import DiAxis at the top of your files, you can actually import a different element namespace if you want. So that's entirely swappable too. And then finally, the drawing layer typically just manifests as your launch function. So in this case, we're using DocAccess Web to launch the app, but you can use desktop, web, you can use our Freya renderers. There's a lot of options. And this is a manifestation of the idea that DocAccess should run everywhere. It should be modular, it should be swappable, and it shouldn't be limited by just a few design decisions that are kind of hindering everyone else. I think Freya is a very cool project. I know the member in our Discord would love to see that I presented it. What's really cool is it's using Skia. So the same thing that powers Google Chrome, the same thing that powers Google Homes across the world, same thing powering Flutter, is what you can use to build native apps. I think this should play video. Yeah, you should see. So the cool thing about this is we're not using web tech anymore. We're diving into a new area of elements. So this is an inline shader that you can actually hot reload. Hold on, let's make it go again. Yeah, I don't have the video on repeat, but you can see like this is a GPU-based shader that's modifying what's being rendered to the screen, which is pretty cool. So things like SwiftUI have this as well. And I think you've seen a lot of it. Maybe if you're on Twitter, you see people building very, very cool modern SwiftUI apps with shaders. Like Metal just introduced this feature, and we've had it for like a year. So it's pretty cool. Some specifics before we get a little too deep into it. The front end web is supported via WebAssembly, this like new budding technology that allows any programming language to run on the web. Server-side rendering is also supported, so you can build statically generated e-commerce sites or your portfolio site or any of these things where like Flutter normally is not a good choice. We also support live view, so your app is run on the server and streamed to the client, so there's like no JavaScript being sent at all. And then server functions, so you can actually write your backend in DocAccess and call your backend directly from your front end, and we handle all the bundle splitting and the binary generation. So you don't need to build APIs anymore. Your functions are right there, and they're automatically split into what's the front end and the back end. We support desktop via WebView, which is the main one, or you can do WTView, which is more experimental, or Skia, which is like the Freya project. And same thing with mobile. We support the terminal via ncurses. There's a cool library in the Rust ecosystem that lets you do this. I'll show it off. And then we're experimentally supporting augmented reality, virtual reality via game engines. So it's not a huge thing yet, but our long-term goal is you can build really, really cool AR, VR experiences with DocAccess. We're not a tech preview. People use us in production. We have very good documentation. If you want to build an app, we have, go to docaccesslabs.com. We have some translations into Chinese. If you want to add more, be our guest. There's a Chinese channel in our Discord, so if you want to like be part of the movement, we'll take it. Yeah, so we're going to do some live coding, and we're going to hope it's going to go well. Okay, cool. Everybody should see my editor. I'm not going to use the thing anymore. All right, everybody see it? All right, so this is like a baseline Rust project. You just created it. There's nothing in it. Usually there's an fn main. Great. I added a bunch of dependencies just so we don't have to go through that process. But it's, I mean, you can add them yourself normally when you get started. We have DocAccess. We have DocAccess router, which we're not going to look at. We have signals, which we're not going to look at. But a few things. So we have DocAccess desktop. So this is just a render that we pulled in, and then DocAccess web. And we're configuring these out to operate differently on the platforms that we're on. So on a web, like the WASM32 target is where we pull in DocAccess web, and on desktop is where we pull in DocAccess desktop. So everything's swappable. You can choose whatever you want. The simplest hello world in DocAccess, we import the prelude. So DocAccess prelude here. We create an app. So all apps in DocAccess are functions, and all components are functions as well. So it's very straightforward. We don't have to think about structs and impls and properties and traits, just functions. So the simplest thing is scope to an element. So we take in this context object. It's very popular in terms of like Rust APIs that you have to have a context object which stores the state of your app. The context object is local, in this case, to just the component that we're in. So this function is a component. We get this cool rsx macro, six.render, rsx. So six.render lets us render any widget layer, and then rsx is the syntax that we use to let you do like widget creation. You can drop in any syntax you want here. So someone in our community made it so you could do the HTML syntax. We prefer more of like a Flutter, Kotlin, like Jetpack Compose type syntax, because that's just more familiar for folks who do like native apps. We can say hi, or we'll say hello world. Save this, and then we're going to use the desktop renderer. So desktop launch app. Cool. All right, we can run it. There you go. All right, great. It's not the most exciting of demos, but it's a hello world. We went from 0 to hello world pretty quick. DOCSIS supports hot reloading, so we talked about this. DXServe, hot reload, platform desktop. We don't have a fancy editor written in DOCSIS yet, of course. But what this lets us do, here, we can change the world, and then it's propagated. So unlike most Rust apps, you are typically recompiling. And DOCSIS, as long as the changes that you made don't affect the Rust code substantially, we can actually patch a running version of your app. So I created a different launch function, launch demo, just for this demo. What this will do is like keep the app alive on top, and also give us some styling and some themes. So the cool thing about DOCSIS is it's HTML and CSS, so you can bring in any themes that you want. I've imported the Daisy UI style sheet. So this is a theme library built on Tailwind CSS, which is like the most popular CSS library right now. When the next most popular CSS library comes out, you can take advantage of it. So yeah, Daisy is really cool. So we can actually pull in some classes. Here, we'll say button. We'll move this over to the side. Class button. And then we can do, it's button. All right, so now this is hopefully you can see, I think the coloring is fine. And then we can like button primary. All right, so now we can like change the styling of our app live. So that we can like bring in all these third-party libraries and components and like just drop them into our app pretty quickly. Hot reloading is pretty cool, so we can make multiple buttons and we can see them all rendered to the screen. This syntax that we're using here is what I call RSX. It's this hybrid of like a Flutter, Swifty type of syntax. It's supposed to be simple to pick up, and it's supposed to look and feel like Rust. So it's all just valid Rust code at the end of the day, like valid Rust tokens, but with a little bit of magic that we do to make it faster, more performant. We're actually able to cache all this code at compile time. So none of this actually gets passed into DOCSIS. It becomes these static templates. The architecture there is pretty cool, and there's a lot of interesting decisions we made. But at the end of the day, it's kind of just this like hybrid meta syntax. You can do a lot of things with this syntax. So you can like map these buttons. So we made these 4 buttons. We can delete them. We can throw a div in there, and then we can do like 4, x, and 0, 0, 0 through 5, and then we can do this. And then the app will hot reload, and then we get 5 buttons. So it's pretty cool. So we can do things like iterators. That's pretty straightforward. We can even do like if true, so conditionals. Again, pretty straightforward. Oops. Cool. These are expressions. So the reason why we don't see the hot reload happen with these things is because this is actually Rust code that we're hot reloading. So we're able to keep most of the state of UI around between renders or between reloads. But some things like just arbitrary Rust expressions, they're not idempotent, is like the term for it. So they're not the same, they're not deterministic between renders, so we can't trust that when we go to hot reload the app that what you're gonna get is real. So we do just a clean wipe of the screen. There you go. So we can even have like child components. So this button that we've made here, we can like put a bunch of them. Maybe we'll give it like a header class. If you're familiar with Tailwind, so is your editor. So GitHub Copilot knows all the things that Tailwind knows. So we can like fly through building UIs. So we can see hello world printed at the top. We can give it like a margin, and we can give it like a background red 300. Wow, it's kind of ugly. Give it 600. Cool. And then maybe rounded, and then maybe P3. Cool, so we can like iterate really quick, and it's just HTML and CSS is what you're familiar with. And it's using Flex as the layout. I mean, it's using HTML and CSS as the layout, but typically you'll use Flexbox as the layout. So it's all super responsive. So if I drag the window, you'll see like the buttons float around. So it's all super familiar. It's what you know already. If we wanted to refactor some of the stuff out, we will just create a new child component. So in this case, fn child component. Let's go. Element. Render. And then we can just rip out some of this down here, put it there. We'll delete these buttons. All the buttons will go away. Nothing's rendered. We'll put the child component in. We need to refresh it because components, again, are not idempotent. They're not the same always between renders. But then we can like create a bunch of these. So reload the app, comes back. Great, so we just did all the work of abstracting our basic UI elements into components. The UI elements are super cool because all of the documentation, here, we'll throw a div in here. All the documentation from Mozilla, like that huge body of work, W3C, is actually in your editor. So if we hover over the div, you get all of Mozilla's documentation right under your editor. So you don't need to go hop out into some third-party page and read how divs work or on-click work or header elements. This is right here. And we can just like click the link, open it, and it takes us straight to the documentation page. So all of the documentation is like immediately under your cursor at all times. Oops. The app is currently pinned on top, so when we float between windows, you keep it around. You're probably asking, all right, we got stuff on the screen. How do we make it useful? We're going to add a little bit of interactivity to the app right now. So in DocSys, you do this through these things called event handlers. Again, HTML, CSS. We'll just use onClick and then move. So yeah, we can attach any Rust closure to any element, and these events are annotated with descriptions for you. So when we do this, our app will need to reload. But now when we go click the button, we should see Hello World in the console. So very quickly, we threw together some interactivity. Again, this is not super enlightening. It's just a Hello World print, but it's very quick that we can get there. If we want to add some state to our app, we're going to go through DocSys' state management system. The primitive for this is useHook. So let state, or we'll say let count equals cx.useHook. We pass in this initialization closure. And what this will give us back is a mutable reference to the state. So this means exclusive. You can write to it. You have direct access to it. If you're used to Rust, this looks weird. This is not a normal API. Typically, you're like dealing with structs and impls. What we let you do is pass in a closure and get a mutable reference out. Usually a big no-no in Rust, but the lifetimes here are very important, and they let us do this. What you don't see is that scope. Here, we'll move this out of the way. The scope object. The scope object has a tick a lifetime attached to it. Let's see if I can get here. This tick a lifetime means any state that originates from scope needs to leave only via that lifetime. So in this case, element also has a hidden lifetime attached to it. So there's a lifetime connecting scope and element. And the things that share that lifetime are these useHook values. So it's a bit of a weird Rust API, like if you think about it. But in terms of usability, it's really cool. So this count value, here we can actually turn on type annotations, is an unmute I32, which means we can do this. We can modify count every time we render the component. So we'll set this up. Let's print count. Count. Cool. It doesn't print until we click. We click it. It's always 1. So that might be weird. So we saw count start at 0, obviously. That's the initial value. We render it once, so that's why we see count equals 1. But there's never a re-render scheduled. With DocSys, you need to tell DocSys that, hey, this component is dirty, some state has changed, you need to go update it. The way you do that is with this cx.needsUpdate. Fairly simple, fairly straightforward. Something has changed. Let's open our console. We click it, hello world. 1, 2, 3, 4, 5, great. So now every time the component renders, the count increases. We can also put this in here. There we go. So now it's not every time it renders, it's every time the button is clicked, which is an important distinction because if another button queued a render, the value would still go up. So we have this basic system of we can store state and we can queue an update. We'll run this. It's not the most enlightening. Like it'll do what you think it does, right? 1, 2, 3, 4, 5, 6. We've built hooks that make this easier. So you don't have to do this for the vast majority of use cases. This is if you need granular control over the rendering engine, like the state reconciliation engine. What you normally would do is use state. We have a lot of state options. Sort of the same API. We don't need this or this needs update anymore. Same difference. So we click it, we should see it, 1, 0, 1, 2. What's really cool, here, let's change this, count. And then we'll pass in count here. So all of these hooks implement the default display formatting system. So you can just pass them in anywhere arbitrarily into the RSX. So now we've made counters. And we've made abstracted counters. So we have different components. They all have their own internal state. So we've been able to create state, add interactivity, and abstract everything out. We're going to take this a step further and build a little chat app, if we can. So we'll see if we can let Copilot guide us. Kind of the basics of a chat app are chats, obviously, a list of chats, so you can be able to interact with it, and then the ability to send messages, send emojis, and I think that'll be able to show off some of the cool things we can do. So to start off with, instead of child component, let's just start basic. So we'll make a list of messages. Typically, the Rust approach is create a messages struct. You need some place to store your message data, so we'll call it a chat. We need the who. We're just going to be lazy. Strings. Actually, we'll make an enum. Who. So me, you. So it's a 2-person chat app. There's actually not going to be another person on the other end of this. It's just going to be AI or AI. But this is typically the Rust approach of designing the data models. We'll have the message, string, and then we'll have some attachments. Yeah, so Copilot knows attachments. So this will be a link to some asset that we want to render in our chat app. A chat app is nothing more than just a stream of chats, a list of chats. So we'll say let chats equals use state, and we'll give it an initial vec. So this would just be an empty vec of chats. We need Rust to know what the type is before we do it, so we'll put a vec of chat. Cool. So when we look, we should get the type hinting. I hope everybody can see this. So you see use state is this wrapper thing that lets us store state inside of it, and then we get a vec of chat. So we can go and interact with this list of chats that we've created. For now, we'll iterate through all of our chats. So actually, we'll throw a header, cool chat app. Let's give it a class. We'll put some padding on it, P2, M2, BG red, 900, rounded. Cool, so we've got all the talent stuff going. So for chat in chats.iter, or actually we'll do chats.iter.map, chat, and then we'll render it. So render, and then every chat is there's a div, and then there's probably some span with the chat dot, what do we say? Yeah, chat dot message. Oop, and then we need to put a comma. Cool, okay. We'll turn on hover loading again. We got the cool chat app. We have no way of sending messages right now. It's kind of lame. We don't see any of our chats. So we need to add some sort of input interactivity. The simplest way of doing this is just throwing an input. We'll let Copilot do all the work, maybe. Type. Text. placeholder, type message, on input, move. So we need some place to store our work in progress chat. So we're just going to have another use state. So we'll come up to here, let current like whip chat equals use state. We'll give it a default string, just an empty thing to work with. We'll make this mutable. And then on input, we're going to set whip chat, like our work in progress chat, to the value that's coming in. So there's this one-way data flow that's happening. We have state that lives at the top of our components. We have event handlers, and then we go and modify the state. So that's not too different than us like having that mutable reference to that state and then setting it directly and then requiring the component to update. Oops. We have one too many brackets. We need some way of actually sending the message. This is like not super helpful at the moment, not super enlightening. So we'll say on key down, and then whenever the user presses the enter key, if e.key does equals enter, and then we'll actually send a chat. So what this is going to require us to do is to modify this chat object and push a new chat into it. Here, we'll delete this. Cool. Make mute. Oh, so this is actually a very good error on Rust part. Like, live coding reveals some things. Make mute requires the clones of the chat object to be made, so we have like an immutable structure in memory. And this is telling us we actually need to add the clone bound to our chat. So we need to come back to our data model, add a derive clone on top of it, and while we're here, we'll add debug, partial equal, all that kind of stuff. Oops. And then, again, good errors. Our enum is not telling us. Cool. All right. We should have a chat app that we can send messages in. Cool message. All right, we can hit enter. Usually the chat apps clear the text input when you hit enter, so we should do that. Oops. So I think I have the code on my cursor. Whip chat dot make mute dot clear. And then we need to drive the input with the text. So in this case, value, and then whip chat. Cool, we should get the hover load. So now when we send a message, it says send message. So we have the things that clears the text input. So we've made right now the ability like a to-do list. We have no ability to remove the chats, which is great because you normally don't delete. We can throw some styling on here. So I'm going to cheat a little. I have some styling that we can pull in, notably on our text input. So we'll give it the same Tailwind class that we've been doing. Oops, in this case, yep. Now our text input field looks pretty cool. Right, it's not too bad. We'll remove some of these background. We'll get rid of this title. So now we've got our text input going. Normally the chats are at the bottom of the app, so we'll want to do some refactoring. Right now we have kind of a complicated app. I wouldn't say it's terribly complicated, but it's enough that this component is kind of getting big, especially for the small screen that we're on. So we're going to do a refactor. We're going to split our app currently into the list of chats and then the chat input. And this is pretty straightforward. So we'll have the chat input component. That's what this will be. Element. We'll move our kind of complicated input element into it. We'll say chat input. Render. And then we need to move the whip chat state into it as well. When we want to share state between components, we typically pass them in actually as the function parameters. So in Doxys, everything's a function. Rust doesn't have the reflection needed to actually assign the names to the function arguments, so we have to annotate it with a proc macro that does that, and then we can pass in the chat. So chats will be a use state of vec of chat. Cool. And then we need to pass in, so we're getting a compile error, which is really good because we're actually not passing in the chats yet. So in where we go to use this component, we have to say chats is chats.clone. Cool, so no compile errors. we've refactored. It took us like all of 30 seconds. We still get our list of chats and our chat input. So the app is doing its thing. We can do the same thing with the chat list. So we'll pull this out. We'll actually just copy a lot of the signature here. Chat list. And then we'll pull this one out as well. So we're kind of going through the motions of building a somewhat complicated app. It's not quite WhatsApp or WeChat or anything like that. Like those are obviously more complicated. But the iteration speed that we get is pretty cool. Here. Now, we need to know who's, we want to be able to send messages to our friends and have them respond to us. For the sake of the demonstration, we're going to do AI. So when we chat, someone will chat back. The AI is just going to echo. So it's not real AI. It's just going to like repeat back with a message. So I'll steal some of that. Them. Who? You? All right, we go. Send a message. Hey, how's it going? Oops. How's it going? Ooh. Grab them. Oh, where'd our chats go? Oh, yeah, because we got rid of we're not rendering the chat list. Oops, chat list. Yeah, how's it going? Cool. And then we need to go back and add this. All right, so now we've got a chat. It responded to us. I think this is not like super useful. It's kind of hard to see. Let's add some styling to it. So this is kind of ugly. But we have this ability to differentiate who's who on our chat app. And we can just steal some of the styling. So I'm just going to come in here, steal all this. Where's our chat rendering? Cool. And then we have one too many of these. Keep going until we. Cool. And then one too many. And then we're using, in this case, enum. So if who did me, this equals who me, and who me. All right. Who me, I don't think does partial equal. OK, cool. Messages. All right. Now we have a chat app. So you should see the bubble. We get the blue bubble on the right. We get someone responding to us on the left. Pretty cool. So this is a functionality given to us by the Daisy UI, like the CSS toolkit that we're using. So it goes to show the flexibility of HTML and CSS as like this core language technology. We were able to just bring in a style sheet and get like this like cool like UI bubble thing. And all this is, if we look closely at the styles that we've done, there's pre-built styles for chat and chat end and chat start. And we can make a bunch of messages. So hi, how's it going? Cool. Let's add like assets, emojis. So everything's been kind of bland. It's just been text and bubbles. Let's add like dogs and like emojis to our app. DocSys supports assets just straight up. So I can ruin our app a little bit. We'll just toss a div in here. An image. Source is logo.ping. Cool. So obviously we support images. It's pretty straightforward too. You just like give the path to what's in the command line. When you go to bundle your app, this like URL is just straight up available to you. So it's very straightforward to add new assets to your app. We can make it so we can even like send emojis. We'll do this. We'll do the async stuff because I think that's the interesting piece here. So we've talked a lot about how do we do like images and state and stuff, but we're going to do a little bit of async work, which again is a big core functionality in apps these days. So in our chat input, we'll come down here. We'll add a button. Here, we'll put all this in a div. Cool. And then we'll add a new button that lets us send like dog pictures. So we added this ability to render assets, right? So the attachments. And then this is just like a URL that's attached. In our chat rendering code, we added the ability to also pull out that attachment. So right here, we're like rendering an image with the source of that attachment. So this lets us do things like, let's go find a picture of a dog on the internet and then render it inline in our chat app. Like as if you're sending images with your friends. Like WhatsApp will give you a URL to render, or it'll download the asset locally. DocSys can do the same thing. So get a dog, or we'll put a dog emoji, and then on click, here, we'll give it a thing. We should see the dog show up. So we have a button, class, flex row. Cool, so now we have a dog emoji next to our chat. We'll put a margin on this one too. All right, that looks like fairly pretty. Here, we'll do a little bit of async. I have a dog API file actually going, so dog API. So this is like if you imported Amazon's API or your own API. This is pretty straightforward. It's just some serialization, deserialization, and then reading stuff from API. So we're going to get a random border collie, and this is going to come out as a string. So here we go. We have, we're going to do dog API, get doggo. So this is like the source that we want to set. And then we're going to push a new message into our chat stream that lets us render dogs on the fly. So this is an async function. So we have to await, but this is not an async closure. So we have to be able to return future. So async move, is like the Rust syntax for that. If you return async closures into DocSys, or like async things into DocSys, it actually knows that's async work and will queue that on the right background threads for you. In this case, this will not do anything. So this compiles, but it doesn't do anything. We actually need to push a new message into the web chat, or no, into the chats. So we're going to do, we need to get the chats into this async context, which is, the lifetimes don't necessarily line up, so we have to like wrap it in this to-owned, and then we'll say chats.makeMute, .push, and then let's see if just Copilot will do it. Yeah, so we have no message, toString, and then we pass in the attachment. Oh, toString. Okay, now I should click the dog, and then we should get a dog. Cool, so now we have the ability to send dogs to our friends. So, hello, world, doggo. And there's some async going on. So cool, that's all you need to build a chat app. We went from like 0 to chat app in like 30 minutes. You can do more faster. All the documentation's out there. Translated Chinese, please. There's a whole world of stuff you can do. We kind of just scratched the surface. There's a lot more like functionality to it, but the focus is developer experience, and we rapidly put this together in all of like 20, 30 minutes. So yeah, we'll jump back to the slides. Oh, we need to close this. Just fly through this. There's a few cool public projects out there using DocSys. Airbus and the European Space Agency are collaborating on like a collision avoidance system for satellites and other nifty aerospace things. Check it out, skytrace.space. They're actually pushing forward a lot of our like web-based tech, so server-side rendering, things like interacting with the major API providers in Rust, Axum, all that stuff. Ebu is a very good example of what a beautiful DocSys app can look like. The sky's the limit on styling here. So this is an open source Mastodon client, like a social media. It looks like a native Mac app, and you can set your own style sheets, so either it looks the same on every platform, or it looks native on every platform. The configuration is also complete up to you. There's another program called Uplink, similar in vein. Again, super beautiful. They're one of our like major supporters. I think probably everyone's asking like, why wouldn't I use X? So Tauri is probably the most popular Rust version of this. It has 60,000 stars on GitHub, it's a lot bigger than us. Tauri, again, is limited by this JavaScript shim layer. So you write a JavaScript front end and a Rust back end. It's not really like the space that we're in, right? You have to bridge between this JavaScript virtual machine into this Rust native layer. With Rust, we can talk directly to the system, which is exactly what we want if we're trying to control a self-driving tractor. And DocSys can run on like embedded and low-end devices in ways that Tauri can't. So you need to bring an entire browser with you everywhere you go. Why not React Native? Again, a lot of the same reasons. DocSys is 100% Rust. We don't need to jump into other languages. We don't need to create like a Swift file and a Java file and somehow bind to those and set up the build process. I think maybe 50% of React Native's code is just a build system to handle this cross-compilation effort. DOCSIS is extremely performant, so it's not bound by the JavaScript runtime. There's no garbage collector, and we're running natively, so we don't get the performance impact. And on Apple devices, you can't JIT JavaScript code. So you have to either run through Apple's engine or run interpreted at like 100x performance loss. And again, we don't have to jump through languages. I think the biggest thing, I've touched on it before, is Flutter. So like, why not Flutter, or why DOCSIS instead of Flutter? Well, 125,000 packages in the Rust ecosystem, so it's a lot larger of a community. And you have developers building things like backends and internet scale network services, embedded devices. Like, what you can do with Rust is just so much larger than what you can do with the Dart ecosystem. And again, we can render natively in the same way that Flutter can, but we're not bound by Flutter's virtual machine engine. And we can reuse all the existing code, like I showed, things like Daisy UI, to like quickly build apps using the tools we know and love. We don't have to go and learn all of like Flutter's styling and widget system. Oops. Yeah, I think we're close on time, so we don't have to talk about all this stuff. I think now is a good time for questions.
好 ，Thank you。有没有任何人有任何问题有关于张生 ？Any questions? You have a question? Go ahead.
Hey, since this project, of course, is super inspiring in React API, and do you plan to keep changing the Oxus based on how React itself progresses over the time?
It's a good question. I mean, we have, throughout the life of DOCSIS, we have had to make like API changes to stay somewhat in line. So React added like things like suspense, and then they kind of like walked that back and like did React server components. I don't think we're gonna go with everything React does, to be honest. Like, we already take liberties in the API. We're React runtime compatible, so you can drop in a React component, which is really cool. Like, they share the same, they don't share the same reconciliation, but they share the control flow. But I don't think we're going to do things like React server components, because it kind of strays away from the cross-platform dream, right? React server components are like getting elements out of the tree, but when you're building a native mobile app, those elements need to be in the tree, because it has to work offline. So yes on some things, and probably no on the majority of stuff that React is going to push forward. Yeah.
Okay. Any other questions for anyone regarding the access? Okay. Thank you very much, Jonathan, for your very fun, exciting, and detailed presentation.